Okay, so the purpose of this lesson today is to just have a quick recap and go over all of the integration stuff that you may need to know. There's a couple of questions, only two questions I want to do today, really. One of which is the most common mistake on the assignment, which I can't speak for Mr. Stratford's class. With my lot, I marked them. Well, I sat down to mark them at about 10 to 1 today, something like that, and I was done about 40 minutes later, which is some sort of record for A-level marking because they were excellent, I've got to say. They were really, really good. So, yeah, I got to say they were very good. So I'm going to do that one question, and afterwards I'm going to have a look at one that involves another area of maths and just a bit of a confusing looking one more than anything. So, what I have on my screen here is just a bit of a summary of some generic rules that we have learned through integration over the last month or so. So the four basic ones, here's a reminder: when you integrate e to the x, it stays the same, but plus c. When you integrate 1 over x, or a fraction like this, where the x, or the term that we differentiate with respect to, is on the bottom, it's ln of x. Technically is the modulus symbol around the x there, plus c. The integral of sine is minus cos. The integral of cos is sine. Now you need to remember them. Others that involve trig, apart from these over here, which we're going to come to in a moment, are given to you on the exam. So these on the right-hand side sort of stem from what I'm doing here. There is a log one as well, which I might do an example of in a moment. But if there is a constant k involved that is multiplying the x term, then you divide by that constant. Okay, so when you are integrating e to the kx, then it stays as e to the kx, but you divide by that constant. Or the way to think of it is you divide by the differentiation of the power. Same thing goes with the sine and the cos. We're going to divide by the k, or it becomes 1 over k. Now this bottom left point is not the nicest definition in the world, but this is referring to a question that might look, let's just get my pen sorted. It's referring to a question that might look a bit like this. Oops, excuse me. Sorry, my laptop's in the way. Might look a bit like this. 4x plus 3 to the power of 7 dx, and we have to integrate something like that. Well, if there is a bracket that's being raised to a power, we sort of treat that bracket as staying exactly the same, and we think of it like, why am I getting 8 from there? Apologies. We think of it like a normal term. The bracket is like a normal term where we integrate, the power raises by 1, and you divide by that power. Now, sometimes it might be easier to write 1 over 8 times like that instead of the 8 underneath, because you also need to divide by the differentiation of the bracket, which in this case is going to be 4. So in other words, we're going to times that also by 1 over 4, like that. And the answer comes out to be that bracket over 32, or 1 over 32 times the bracket plus 8. So that's what this rule is all about here. Now, there's another rule, like I sort of mentioned earlier, was one to do with ln of x, which is something that maybe we were a little bit struggling on sometimes on recent assignments. But if we have something that looks, let's pick a question now. If I'm integrating this, okay, if I'm integrating that, well, this rule over here that's going to apply, where if there is a fraction where the x term is at the bottom, like this, so it's ln of something, then you need to be quite careful of this one. Now, first of all, the 2 on the top is sort of timesing the whole function, so that can stay. You can sort of bring the 2 outside the integral, or in your answer is just going to be 2 times everything. It's the same as saying 2 times 1 over all of this on the bottom. So that's 2 times ln, when you integrate, of 5 minus 4x, in a modulus symbol technically, plus c. However, as with these other 3 here, you also need to divide by the differentiation of the bracket, or in this case, the bit on the bottom of the fraction, or the bit inside the ln symbol there. So you also need to divide by minus 4 in this case. So they would cancel out and it would become minus a half, all of that. Let's write that a little bit neater. Minus a half ln 5 minus 4x plus c on the end. Now this little box in the bottom right was of use within some exercises, not the most recent one, but the one before that. If we know our trig identity, specifically the cos 2x one, then I can replace sine squared x and cos squared x by the rearranged version of this identity, which is, well, is the cos 2x identity. And basically you can't integrate sine squared x or cos squared x, but you can integrate something that looks like cos 2x. So if we rearrange that identity, you can substitute something in that might be a bit nicer. So those are my sort of generic basic integration rules there. Coming up next, remember, it's just a bit of a recap now. Integration by parts was also important. I'm not going to do an example because I think I remember rightly the assignment was excellent that we marked on this. But we also have this integration by parts formula that you have to remember. So that is when you have two terms multiplied by each other, and you can call one of them u, one of them dv by dx, and you create yourself a little box to begin with of u equals and dv by dx equals. You can then differentiate u to give you du by dx, and you can integrate this to give you v equals. And then it's a case of substituting those things into this right-hand part of your integration by parts formula here. Okay, so you have uv minus the integral of v du by dx. That needs to be memorized. So that's going to be useful again for the exam or test, whatever we give you. Okay, so there's a couple of that's it, apart from substitution, which we've only just done, so I'm not going to do a full recap of that. However, this question was one that caused problems on the homework. Not the homework, the assignment, whatever you want to call it. Okay, so the question is this one here. The integral of e to the x over 4 minus e to the x dx. And the substitution they wanted us to use is u equals e to the x. So remember, with substitution, you've just done this. Some of you may well have had this right in your homework, in which case you can just ignore me for 5. If you didn't get it right on my lot, I maybe wrote in the comments that I was going to do it today. So obviously pay attention now. So when you are substituting, you have a certain process to go through. They either give you a substitution or you need to work it out yourself. In this case, good news, they've given it to us. So I've got to differentiate. So it's going to be du by dx. Differentiate that substitution, it stays the same. Okay, it stays exactly the same. It is e to the x. However, you need to rearrange that to give you dx as the subject. So that becomes du over e to the x. And this first line, this last line are the two things that usually need to be substituted in. So I'm going to do that. Okay, so if I substitute them back into my original equation, I don't want red. I put them into my similar original equation, which was e to the x over 4 minus e to the x. If I sub them in place, then u is equal to e to the x. Now, this substitution, I think the most common mistake people did on their homework was they maybe only put it in one place or missed it out, but it actually sort of happens twice. However, there's no need to put it in twice. Okay, you don't need to put it in on the top, on the bottom. I'm actually going to leave e to the x there for now on the top. You'll see why in a moment. But the bottom I'm going to replace by 4 minus u, because u is e to the x. And dx I'm going to replace by du but over e to the x. So the reason I kept that e to the x there on the top and not replace it by u is because it cancels out nicely with that one there. You could have replaced it by u, as long as you also replace this one on the bottom by u, because they'd cancel out. So you are then left with the integral of 1 over 4 minus u. Some people just left it as 4 minus u. No, it was, remember, this cancels out on the top. You can't just disappear at the top. There's a 1 there, technically. So that is now that du. Okay, so on the previous slide, we discussed how to integrate a fraction like this, where the term I'm differentiating with respect to is on the bottom. It is ln of 4 minus u, but I need to divide by the differentiation of this bit here, or this bit here. So you're dividing by -1, technically, which is just going to be a minus in front, like that, plus c. And don't forget, we need to sub back in what u is. In this case, that is e to the x, and a plus c on the end. So there's your full answer for, that was 1J, by the way. This is the question that people struggle with on the homework, 1J. Okay, there's only one final question I want to do, which is a little bit different, but it crosses into another area of maths. So the last question I want to do is this one. It's a bit blurry on my screen, this question, because of the way I've copied it, so apologies for that. Write it again, in case you can't read it. It is the integral of 2 over x squared minus 1 dx. So it's not substitution, this. It says to use partial fractions. Now, partial fractions is not an integration topic. However, we've just done that recently, so let's see how much we can remember, I guess. So we have the integral of 2 over x squared minus 1. Now, it wants us to do it in the form of ln f of x. Now, don't just jump into straight doing like ln of the bottom, like the rule I've just been telling you, because I'm not sure it'll necessarily work here. Plus, the question tells me to use partial fractions. Just realized my laptop is about to run out of battery. Hang on a moment. Plug in. Okay, today. So, partial fractions. What we need to do is use the topic of partial fractions on 2 over x squared minus 1 to maybe create something that is easier to integrate. So, it's not substitution. It's not any area of integration particularly, apart from I will have to use ln at some point. That's new to us. So as you remember, with partial fractions, hopefully you remember, that is when usually the denominator is in bracket form. Now I can write this in bracket form because this is difference of 2 squares. That's x plus 1, x minus 1. And with partial fractions, we separate that into a, well, write this slightly differently now on the next line. We can separate this now into a over x plus 1 plus b over x minus 1. And it's our job to find out what a and b are. So if I write this a little bit neater, it was, remember, 2 over x plus 1, x minus 1. I'm writing that in a different form that looks like this, which will hopefully be easier to integrate because that's the point of this question. Now, the step with partial fractions is, let's get rid of any denominators. So I'm going to multiply through by x plus 1 and x minus 1. So I'm going to times this one by x plus 1, x minus 1. I'm going to times this one by x plus 1, x minus 1. That will cancel out that on the bottom there, that on the bottom there, this on the bottom, this on the bottom. And you are left with a brackets x minus 1 plus b brackets x plus 1. Hopefully this rings a bell, sort of, because it's just showing you a question where different topics cross over. So with partial fractions, we need to remove one of the a's or b's one at a time, and we do that from choosing some values of x. So I'm going to choose x is 1, because if I sub that in, I get 2 equals a times 1 minus 1 plus b times 1 plus 1, which will get rid of the a because 1 minus 1 is 0. So I'm then left with 2 equals 2b. So b is equal to 1. Scrolling down. The other one I need to substitute in is -1. So we're going to have x equals -1. So I get 2 equals a times -1 take away 1 plus b times -1 plus 1. I'll end up with 2 equals -2a, and a is -1. So my original question all the way up here, where it was the integral of 2 over x squared minus 1, well, I've now rewritten 2 over x squared minus 1, well, I'm about to, in a different way with these a's and b's. I'll write it up here and I'll copy it down in a moment. This has now been changed to, this whole thing has now been changed to, well, a I just worked out was -1. So that is -1 over x plus 1. And b I worked out was 1. So that's going to be now 1 over x minus 1 dx. I've changed my original question to this. Ooh, no, not that. To this here. Put that down the bottom. So now it's just a case of integrating this. This on the right is actually easier to integrate than this in the first place, because this comes out to be, it's just basic ln ones here. So this is minus ln of x plus 1 plus ln of x minus 1 plus c. And we can combine these together as an answer. Okay, it's perhaps a little bit easier to write them the other way around, because you'll see why in a moment. Oops, excuse me. If I write them the other way around, it's exactly the same answer. I'm just writing the -1 second. You can combine logs together. So when you are taking logs away, you can combine them underneath the same log as a division sum, like this. And that will be the final answer to that question. So not straightforward, but this shows you why you can't necessarily go straight into doing like 2ln of the bottom here, because what you have is like a squared x on the bottom. That changes things slightly. If it was just a normal constant, not constant, if it was a normal letter on its own, you'd be able to do it, no problem. But this is a bit of a different question. Okay, so that one, just a very random integration question on the end that has combined a couple of topics this year. Now, I think integration is potentially the most difficult topic in general this year. I think we've coped very, very well with it in general, especially because of the nature of remote learning. So just a general well done from me and Mr. Stratford on that one. And that's it for today. Okay, so unless you have any questions, guys, off you go.